We've been seeing the words differentiable and continuous on those other papers, and we have covered them when we're dealing with equations, and hopefully you have seen what happens. You just get the derivative when x is less than the value, when x is greater. We've seen for that. Now we are dealing with differentiation itself, and particularly the rules, some other rules to add to our thing. So let's go through it and let's see how it goes. So for here, we are going to be continuing here. Then the last thing we'll do is application. And guess what? You'll be having the theory you need. All you'll be needing is practice. So here we've done with the equations. Don't worry about it. Now we go to differentiation. Differentiation. And first of all, what we want to talk about is we want to talk about the rules. Okay, the rules that we're going to be using. And we have seen that number one, we have the power rule, right? So the first rule you have, actually you'll be having 4 rules, but it then starts adding to next and next and next and next thing. But here you'll be saying differentiation. What do you do here? So differentiation, here we have it like this. Here's your derivative. So power rule, we have power rule. We have the second rule is going to be the product rule. Then the other rule. I want you to just know your differentiation by heart. It's not hard. This is going to be the easiest thing ever. Then there's the quotient rule. Then we are going to have the fourth thing, which is going to be the chain rule. I want people to know these by heart. There's a lot to say on this, but I'm just going to be to dwell on some of the things, and then we'll get better and better with time. So here we have the power rule. So power rule is what everybody does without knowing. It's like if you're asked, what is the derivative d dx of 5x squared minus 2x plus 7? What is the derivative of this thing? Well, we know that what you do is you drop the power, you reduce it by 1. So it is like 2 by 5, you get 10x. Then the derivative of negative 2x is just negative 2, because x now becomes x to 0. You ask me, what are we using here? We are using the power rule. This is the power rule which you have been using. So this is all the power rule. Now, what does the product rule then say? So power rule is just one you use when you have these type of things which are called polynomial functions, okay? We call them polynomial functions. In fact, let me just show you the types of functions. I believe I've done that before, but I'm going to show you again here. We use the word lepeth. L is for logarithmic functions like ln x. Okay, the function can say y equal to ln x or y equal to whatever. Here is a logarithmic function. Okay, y equal to ln x. Another one, y is equal to log base 2 of x. Here is another logarithmic function. Then here, inverse trig is going to be sine inverse of x. Okay, you haven't really dealt with this, so we'll see with time as you do. But just know that we have y is equal to cos inverse of x, y is equal to tan inverse of x. These are inverse trig functions. Then we have polynomial functions. Y is equal to x squared plus 5x minus 9. This is a polynomial function. Polynomial functions just have numbers and x's and or numbers and t's and whatever with powers. Then we now have exponential. Exponential is just one way your variable is now the power. So for example, y is equal to e to the x. This is an exponential because x is now the power. We have again y is equal to a to the x. This a is just a number, so it's like to say 7 to the x. Here is another exponential equation, exponential function. Okay, these are exponential. Why? Because x is the power now. So this is an exponential thing. Then we have t. T represents trig functions themselves, which is y is equal to sine x. Another one, y is equal to cos x. Another one, y is equal to tan x. All these are just trig functions, okay? All these are trig functions, right? Can you see that? So these are trig. Y is equal to tan x. Then we have y is equal to sec x. All these remember there are 6 trig functions. We have y is equal to cosec x. Then we have y is equal to cot x. These are all trig. Then here we have hyperbolic trig functions like y is equal to cot hyperbolic x. Then you have y is equal to sinh sine hyperbolic x. Whatever. All these are now hyperbolic trig functions. So here we have all these. These are types of functions that we have. Now when we come here and we are now talking about product rule and all this, you will be having something in the form y is equal to uv. Where you say where u and v are functions. Remember, these are functions. These are not values. These are not variables. We don't have u as a variable like x and v. No. These are functions. U is going to be something, y is going to be. For example, if you get y is equal to e to the x cos x. Here is an example of product rule. You have two functions multiplying. What is e to the x? E to the x is going to be an exponential function. What is cos x? Cos x is going to be a trig function. And we have these two multiplying, so we have to use the product rule. So you're going to let the first one be u, the second one be v. Once you have that, you can find your u prime. You let this be u, you let this be v. Then you can find your u prime, then you can find your v prime. You can find them, then you're going to apply the product rule. So in here, I'm not going to be doing the application. In the application, we can do it, but I want you to know the product rule so you can apply it. What does the product rule then say? If you now want y prime, the product rule then says, if you want y prime, y, which is the derivative of y, it's going to be bring the second one, which is v, multiply by the derivative of the first, plus bring the first one, then multiply by derivative of the second. And this will give us the derivative. That is how you get the derivative, and that is the product rule. Remember it, the second times derivative of the first, plus the first times derivative of the second, and you are done. You are done. Now what about the quotient rule? The quotient rule is for two things dividing. Y is equal to u over v. We have two things dividing. It's like you have y is equal to, even if we make it like x plus 5 to the power of 3 all over x squared minus 9 or x squared minus 2. This is something which we can use the quotient rule on. You see, the one on the top and whatever, we're going to talk about it though later on. Even if we have something like y is equal to sine x over this. These are two different functions dividing, because the one at the top, what is it? It's a trig. The one in the bottom, what is it? It is a polynomial. And what are they doing? They are dividing. So how do we then get the derivative? Now I want you to remember the quotient rule. You guys, I'm giving you a cheat code now. I'm about to give you a cheat code, which I want you to use to remember the quotient rule. Remember, the one in the bottom is going to be low. The one in the top is going to be high. Okay? So there's low and then there's high. Now we can use this to get our derivative. How do you say it? Remember, Clarify told you this, that the derivative is going to be low, which is v, d high, that is the derivative of the top, which is u prime, minus high, which is u, d low, which is the derivative of the bottom. D low is the derivative of the bottom, which is v prime. O over square the bottom, which is v squared. So what is it, the quotient rule? Low d high minus high d low over square the bottom. This is going to be the quotient rule, and you can find it. If you mix it up, you're gone. You can't say high d low minus low d high. No. Remember, it's low d high minus high d low over square the bottom. That is how you do it. You should be able to make this and you'll be done. The application we'll learn. The application you can see in the tutorial solutions, which I've posted as well on the site. Okay, you can see the tutorial. I've put every tutorial solution for you. But here, the first thing is how to do it. You must remember the formula. Now we have the chain rule. Chain rule is going to be the last thing. And in chain rule, you can see them say to you, either they'll say, please express u as a function of x, u equal to g of x, and y as a function of u, y is equal to f of u. This is for chain rule. Now there's something I want to teach you in chain rule, which is going to be the key to us mastering. It's going to be the key to us mastering the next stage, which is the common derivatives table. So what is it about this chain rule? When do I use chain rule? So we've seen product rule, you use it when you have two functions multiplying. Quotient rule, you use it when you have two functions dividing. Chain rule, you use it when what? That's the question. You use it when you have a function inside another function. And the examples are endless. And these are 99% of the situations you're going to get. You will hardly be given an ln x. ln x is the logarithmic function. It is the proper logarithmic function. But you will get it as y is equal to ln, then they say x squared minus 5, like this. This is no longer ln x. And if it's no longer ln x, it's no longer just a logarithmic function. It's now a composite function. What do you mean by composite? We have a function inside another. What is the one inside? It is a polynomial. What is the one outside? It's a logarithm. So we have a polynomial inside a logarithm. So this is now an example of what? Of a composite function where you use chain rule. Or if you have y is equal to x squared minus 3x all to the power of 6, like this. This is no longer just a polynomial. No, because we now have a polynomial inside, but it's raised to another power outside. So this raising to a power is a polynomial action. It's an action done on polynomials. Then here we have another polynomial inside. So this is the inside function. Then the outside one is raising to the power of 6. So the inside one raises to the power of 6, then subtracts times the triple of u. That is what it does. Then the outside one raises to the power of 6. So this is again a composite function. We have a function inside another. Then we can have y is equal to, we can have cos of 3x squared. Whatever it is, you know, we know that y e to the x is the function, but we can have y is e to the negative x. This is not x. Negative x is not x. So this is another composite. All these are examples of composites because you have seen the trig. Trig was just cos x, but now this is a 3x squared. It's not an x. So we have something which is not an x, which is there. So this is a polynomial. 3x squared is a polynomial which has been put inside of your trig. So now that is a composite function. And how do you do it? We can do it the longer way. The longer way is you will always let u be the inside. So it's like you come here, you will say, let u be equal to the inside one, which is x squared minus 5. So it will be u equal to x squared minus 5. And that now means that y is equal to, instead of ln of x squared minus 5, it's now ln u. And that is what we have said you have done. You have made u a function of x. U is a function of x here. And you have made y be in terms of u. So you have made y being. It happens naturally by doing the first step of the chain rule. So you need to recognize, oh, this is a chain rule problem. Once you have it, now you can differentiate u with respect to x. But we no longer write u prime. But u prime, v prime, they are for product rule and the quotient rule. Here we will now write, instead of u prime, we'll write du dx, okay? And what is it? The derivative of u with respect to x, you drop down the power, it becomes 2x. Then the derivative of minus 5 is 0. Now, what is the derivative of y is in terms of u? We'll get dy du. The derivative of y is in terms of u. So it's the derivative of y with respect to u. And that is the derivative of ln u, which is just 1 over u, okay? Now, once we have this, we will now apply the biggest formula for your chain rule. It just says, if you now want dy dx, it is going to be dy du times du dx. And this dy du and du dx, you get them naturally. So dy du, do I have it? Yes. Du dx, do I have it? Yes. So I'm just going to now say, multiply those two. Dy dx is just going to be dy du, which is this one, times, which is the one you normally get the second time, du dx, which is the one when you differentiate y. So it will be 1 over u times, what is du dx? 2x. And here 2x will just now go to the top because it's a whole number. 2x times 1 is 2x over u. Now it's going to be 2x over, what is u? We go back where we said let u be, which is x squared minus 5. So it's 2x over x squared minus 5. And this is your derivative and you are done. Although I'm going to show you a shortcut using the common derivatives table, but this is the longer way to do it. Okay, this is the longer way to do it. Wow. Is this the longer way to do it? Yes. What is the shorter way to do it now? Let's just talk about the shorter way to do it. Let's bring back this y is equal to ln of inside, we said x squared minus 5. How do we get the derivative of this? And you're going to see them do it a lot. It is even there in your slides. So don't think I'm doing it the wrong way. Don't think this is the only one there in your slides, this longer way. It was there when they were teaching you how to do it. But now when you become a master at it, they now tell you the shortcut. It's still there in your slides. You see it. If you go to lecture 6, derivative 6, now you differentiate this. You start by differentiate. This is how you differentiate a composite function. This is how you use the chain rule as a shortcut. And this is the secret you're going to need to understand the common derivatives table. It is this. When you are doing chain rule, first you will differentiate the way you differentiate the original function. So you'll be saying, this is ln of something which is not x, but first I'm going to differentiate it the way I differentiate ln x. Now, I know you don't know the derivative of ln x yet. I'm going to show you. That's why you may have been confused when I said 1 over u here. But don't worry, it is in the next video where we talk about the common derivatives table. The derivative of ln x ddx is just 1 over x. This is the derivative of ln x. So now we have something which is not an x. How do we do it? First, we differentiate the outside. In other words, we focus on the ln. And we ignore that the inside is not an x. So how did we differentiate ln x? It was giving us 1 over x. So how do you differentiate this one? We will just say 1 over this, okay? this, which is x squared minus 5, the same way we did 1 over x. Then when you are done like this, you then multiply by the derivative of the inside. So how you do for the things which are something which is not an x, we'll be saying this is y equal to f of x. Okay, which is y is equal to, ln of f of x. In other words, it is ln of something which is not x. In here we say y is equal to ln of x. But in here we say it is y, it is fn, y is ln f of x. So when ln x, when we differentiated it, it was giving us 1 over x. This one will give us 1 over f of x, which is the thing inside. So you just do like you're differentiating ln x first. How do you differentiate ln x? You just get 1 over x. So how do you differentiate ln this? We just get 1 over this. But then you then multiply by the derivative of the inside all the time. You're going to differentiate the outside, and when you differentiate the outside, you ignore that the inside is not an x. You treat it like you would have treated an x. But then when you're done, you then multiply by the derivative of the inside. What is the derivative of x squared minus 5? It is 2x. So then you will now end up having 2x over x squared minus 5. Is that the answer I got here? Yes. Oh my goodness. I get this answer without even doing too much? Yes. You ignore that it's not an x. That it's not an x. Then you, after doing for it as if it was an x, but then you put it not as x, you put it as what it was in here, but then you then multiply by the derivative of the inside. And that is the shortcut to the chain rule. So what was I teaching you here? The product rule, you have seen what it says. The quotient rule, low d high minus high d low over square the bottom, which is to square the lower thing. Then the chain rule, we've seen what it says. In the long thing, we saw that we let u be the inside thing. Okay. In here again, we were going to let u be this inside thing. In here, we're going to let u be the inside thing, which is 3x squared. Here we let u be the inside thing, which is negative x, and you would have y is equal to e to the u. Okay, negative x will become the u, and you can now differentiate and e to the u. We'll talk about that. So this is so easy, and everything is a walk in the park. That is what you do. And remember, once you have that, everything becomes a walk in the park. That is it for this first part. Now in the next one, we're just going to talk about the common derivatives table, which is a table which we use a lot. Then once we're done with that one, the final thing is to talk about application. And we say to you, bravo! Okay, goodbye for now.